Now that we have seen how to write a multi-threaded program, let us see what are the troubles that we face with a multi-threaded program. Now when I have a multi-threaded program, since all the threads share the same memory resource, so whatever information that I have stored is also shared by all these threads. And when I have a shared data between threads and all the threads manipulate on the shared data, finally the information might be wrong. For example, let's say a railway reservation counter. We all go to a railway station. We want to book for certain number of seats. So what we do, let's say one person goes to one counter and another person goes to another counter to book for tickets for the seats on the same train. So when they go to book the seats, what does the counter do first? It finds out how many seats are available, and then they let you know whether seats are available or not. Depending on that, they book. So when both the counters request for the seat availability, do they request into their own machine? You mean to say the data will be available in each and every counter's machine? Doesn't make sense, right? It will be available in one centralized area, in one centralized machine. So for this centralized data, okay, these two counters are threads. This centralized data is being shared by these two counters, and when both these counters request for the seat availability, they both contact this common data and get the seat availability. Let's assume 10 seats are available. So they both get 10 as a value. Now one person who has come to counter 1 says, I want 3 seats. Counter 2, the person says, I want 2 seats. So finally, how many seats should be available at the end of the entire transaction? 5. But now what happens is, what could happen is, remember both have inquired how many seats are available, so they both end up getting 10. One counter updates by subtracting 3, another counter updates by subtracting 2, and they both say update. When they update, this counter says update to 8 and this 7, and this counter says update to 8. Finally, the updation could either be, the seat availability could either be 7 or 8, or it could also be 5, but there is no guarantee that it's going to be 5, right? So it has to be 5 actually, but there is no guarantee on this, because both threads are accessing the common information at the same time. So what you need to do is, you need to make sure such common information being accessed by multiple threads should be done one at a time. So one counter inquires and transaction ends, then only the next counter should inquire and end the transaction. So that at any point, only one thread manipulates the information, and once it is done, the next thread manipulates. So I'm guaranteed that the data or the information is correct. So in order to achieve this, we use what is known as synchronization. Synchronization is nothing but placing a lock on an object, so that only the thread which has placed a lock can access that particular information, and once it is done, it releases the lock so that the next thread can access it. To work with synchronization, you use the modifier called synchronized. Synchronized modifier can be used against a method or as a block. Again, I repeat, synchronized is used to place a lock on an object. On a object. This is very important. Okay, the lock is placed on an object. It's an object lock. So let's see how to write this. So you say synchronized against a method, or you can have synchronized as a block inside the method. Either one of these situations. What is the difference? Now, the difference is a method is written inside a class. So, in order to access this method, you are going to create an instance. Using an instance, when you invoke a method which is synchronized, the object which is used to call the method is the one which gets locked. So if this is in class A, I have a method, synchronized method M in class A, let's assume. I create an instance of class A called A1. And using A1, let's take this. Let's say class A. I have synchronized void M. In order to access this method, we create an instance of A. Using A1, we invoke the method M in some thread. Let's call it as thread 1. Thread 1 calls A1.M. Since M is a synchronized method and M is called through A1, now you have object A1, right? This object has many instance members, plus it has a pointer to the method table, okay, and also it has a placement for lock. So when I call A1.M, since M is a synchronized method, thread 1 is calling M, so thread 1 places a lock on object A1. So when it says it's placing a lock, now here the information in the lock changes. Now it will be either 1 or 0, 1 for lock, 0 for not locked. So it changes to a lock. So it places a lock on this object A1 because that's the object I used to call this synchronized method. When does this memory space for lock get created? Now it really depends on the JVM implementation. The JVM can allocate a memory space for the lock of an object either at the time of creation of an object or the very first time using that object I call upon any synchronized area. Either one of these cases. It really depends on the JVM. So anyway, I have a placement for lock which gets converted from 0 to 1 or 1 back to 0. So I place a lock on object A1. Once I complete this method, I come out of the method M out here, then this lock is released by converting back to 0. Now let's say if thread 2 was also trying to call the same M using this object A1, now what happens is since T1 had already placed a lock and was inside the synchronized method, T2 which has tried to call M cannot get into the method M because T2 also requires to place a lock, but the lock was already placed, so he cannot place a lock again over it. It has to wait till T1 completes the execution of M and then releases a lock, and when the CPU time is given for T2, then it places a lock on A1 and then goes into the method. So at any point only one thread can access a synchronized area by placing a lock on a object. Now, how is this synchronized against a method different from synchronized as a block? Now let's assume instead of synchronized being specified here against a method, I specify it as a block inside here. Now in this case what happens is, synchronized as a block, since the object that you have to pass as a parameter here to this block, okay, it can be any object. If it is the current object itself, the same class object itself that you want to lock, you can just say this. If it is any other object actually which you require to lock and not the current object, then it is synchronized block is very useful. Assume the thread is calling M, method M, but it is not A1 that has to be locked, rather some other object which has to be locked, then better to use the synchronized block rather than synchronized at the method, because synchronized at the method will always lock the current object.